Now, my goal with this episode is simple. It's to approach the data as objectively as possible and to dive deeper into the science, which short sound bites do not allow for. I've done my best to supply you with any of the articles or studies that Dr. Parker refers to, and I encourage you to approach that data with the same level of objectivity. Please keep in mind that none of the following is medical advice, just a conversation between two interested scientists. Consult with your doctor on any questions about care. And with that, join me in vivo with Dr. William Parker on the link between acetaminophen and autism. Dr. Parker, my goal with this episode is to approach the link between Tylenol and autism really from a first principles perspective. As a scientist and a parent, I really want to understand what the data shows, the molecular mechanisms, and how we got to where we are today. So why don't we set the stage with a little bit about your background and how you found yourself speaking with Secretary Kennedy?
Okay, all right, Tim, thank you so much for having me here. So my background is in chemistry. I have a PhD in chemistry, 1992, University of Nebraska. And Lincoln. Then I've worked at Duke for almost 28 years, not quite 28 years, and now at the University of North Carolina, Chapel Hill as a visiting scholar, and I have a private nonprofit that's focused on research and education. So that's my story in a very brief nutshell. The science that I've done over the years has been a lot of immunology. I've got chemistry, obviously. We've done a lot of work in the microbiome. I'm probably most well known for discovering the function of the human vermiform appendix, which is something Leonardo da Vinci was working on. So just right place, right time, serendipity, that kind of thing. So very exciting. I'm also well known for looking at the immune function of wild rats and how intestinal worms help modulate our immune function. And they have a lot to do with neurological health as well as autoimmune and allergic disorders. So I'm sort of like a fungus on Google. If you Google me with all these different things, it's just everywhere. It's a lot of fun. It's a lot of fun science. But in the last decade, we've really delved into, and it came from I was renowned in the field of sort of gut biology and how the immune system works with the microbiota. And then that dovetailed into our work on autism spectrum disorder, and sort of how that's different from a lot of other chronic inflammatory related conditions.
And like you said, serendipity is a wild thing in science, isn't it? How things right place at the right time. That's how it tends to work a lot of the time. But what initially drew your attention to this whole theory or debate or issue of acetaminophen and its potential in causing autism?
Yeah, so we had figured out what the human appendix does, which begs the question, well, why do you have appendicitis?
Yeah, right.
And at that time, I was also, we knew that hunter-gatherers don't have, and this has been known since the 1960s, they don't have the same kinds of chronic inflammatory problems that we have. So we were interested in using wild rats to compare those with lab rats, because lab rats are sort of more like us modern clean humans, and we're looking at which organisms might be different. So it had, we were really digging deep into this broad spectrum of immune issues related to inflammation, related to changes in our culture, because we have toilets and clean drinking water, and there's no way, I went into my refrigerator today and grabbed a bunch of food and for breakfast, and there's no way I got a parasite. It's just not possible. So all those kind of things. But then you look at autism, and you're like, okay, all right, it has sort of chronic inflammation, but there are some things that are really different, especially the timing of it in history. Mm-hmm. So, that's where science gets really fun, is where you see something that doesn't make sense. And right. You don't want to focus on the things that make sense. You want to focus on the things that don't make sense. And then when you break through that, and then everything then makes more sense, then you're in a better place scientifically.
Right. It's a good jump off point. Let's solve the things that we don't understand.
Exactly.
So I think, as I mentioned, first principles, I love approaching science and topics this way. So, what better place to start than just defining autism, ASD? What is it? How does it present? What are the symptoms?
Yeah, so autism was first really described in 1925 by a Soviet clinician named Grunya Sukhareva. And the description I'm going to give you, any clinician who works on this would say, wow, that guy is obviously a PhD and doesn't know anything. But I'm just going to give you the criminally oversimplified version of what autism is, right? So there's three basic sort of diagnostic pillars for that. And one is problems with social awareness, impairment with social awareness. And then there's repetitive behaviors, and then there's aversion to new stimuli, right? So those three kind of things. And then, of course, it is a spectrum. You can have different amounts of the empathy can be off kilter, either positively or negatively. There's a lot of other things that are not part of those three. And you can have, impairments in motor skills. You can have, in different kinds of profoundly problematic issues with cognition, right? Just inability to speak. There's a percentage of people that'll never even learn to go to the bathroom. So it can be very, very challenging. For a third, it's just debilitating. Maybe for a third, then it's very, very hard, but maybe not completely debilitating. And then for a third, it's sort of these are the quote unquote high functional people, but it doesn't mean life is easy. It just means that they're high functional.
Now, as the acronym or the name would suggest, it's a spectrum disorder. So I'm saying that because I want to remind myself, I want to get back to the idea of it being a spectrum and perhaps how your hypothesis works into that. So before we get into your hypothesis, Tim,
let me say,
please.
At this point, we would not call it a hypothesis. We would say, based on available evidence, our level of certainty moves us way beyond.
Okay. Fair.
And, the term hypothesis in theory, scientists really don't use those anymore. I'd say we're beyond what we would call a working model. I mean, we're very confident about what's going on. So the more uncertainty comes in when you get into the details, like exactly how much autism comes from, say, when you clamp the umbilical cord versus during pregnancy. That's where, when you start asking details, we're less certain, but we're definitely beyond the hypothesis level. Right.
No, that's a good correction. And when these things come to fruition and become practical, and by that I mean the press conference and the suggestions and the labels that are going to be changed, I mean, it's beyond hypothesis at that point if you've got concrete action that's being taken. So now this idea is not a new idea per se. I mean, it might be new to many people because of the press conference that happened. Is it fair to say that the idea has been floating around for at least 20 years?
2009.
2009. So close to about 20 years.
Well, so the hypothesis was 2008 first proposed, but then 2009 there was somebody, his name is Peter Good. He put together enough information so that it really at that point, and this is 2020 hindsight, but if you look at everything that Peter Good knew, and even things that he could have known at that time that he maybe was unaware of, there was enough information in 2009 to say, okay, we need to take action on this. We need to move it beyond the hypothesis level and say, especially with working with children, there's something called the precautionary principle. So maybe if you're only 20 or 30% sure, maybe you ought to go ahead and take action, right? So
do no harm. Yeah.
Yeah. Well, so do no harm that's technically not a valid. I mean, you can't do any good if you aren't willing to do any harm. So that's a tricky one. But the real statement should be intentionally do no net harm. So that should be the actual statement. So in 2009, we probably an objective look at this, and objectivity is part of the gold standard of science. In 2009, I think if we were objective at the time, we would have said, okay, it looks like we're doing net harm. We need to stop it.
Now, before we get into the specifics, which is what I want to dig into, what were the prevailing ideas, models, theories, hypotheses that existed prior to 2008 that sort of were popular, I guess you could say?
Well, so there's one that it was based on the observation of parents that, vaccines are causing autism, and that's not accepted in mainstream. But the observations of parents have historically, since the 1940s, always been very, very useful. And we in the mainstream scientific field ignore them at our own peril. And there's repeated history of us in the mainstream scientific community making mistakes with that. It doesn't mean that their conclusions are correct, but we need to pay attention to their observations. So that's one. But the other main prevailing things are sort of what we have today, which is there's sort of two camps on this. and then one camp is divided in two parts. But anyway, so the one camp is that it's mostly just changing diagnostic criteria. And then,
Right.
yeah, and the other, and then there's no real pandemic of autism. And then the other camp is more along the lines of, well, it's a very complex mixture of genetic and environmental, and then the magical combination of genetic and environment called epigenetics. And so all this sort of cloud of complex interacting variables that are causing autism. So, and that's the more accepted one, because most, there's a lot of ways we know there's so many ways we know that it's not just changing diagnostic criteria. Now, that being said, yeah, if something becomes much more common, we're naturally going to get better at diagnosing it, right? So in theory, if you could do the experiment where you went back in time, grab Leo Kanner, who described this in the 1940s, and bring him to today, he'd probably miss half the cases. He probably wouldn't get the really mild ones. He probably wouldn't get the super severe ones. But that's just a matter of as something. So it's sort of true and unrelated. Yeah, we are better at diagnosing, but that you can't extrapolate back and say that, well, that means that Leo Kanner was missing, 95% of all the cases. That's not what that means.
So, yeah, no, I mean, it is true that the DSM-5 was changed in 2013 to broaden the definition a little bit, but you're right. You can't go back and use that retrospectively to answer a lot of that, to digest that data.
Thing is, yeah, if you look at that change in 2013, it's like, how much did it really broaden things, right? And you already had him, and that's questionable. That's everybody uses that. But if you really dig into that and read what people are saying at the time, well, it shouldn't have changed things very much. And then you look at guys in the 1980s writing, and these are, in the 1980s is when autism pandemic took off. So these are the same investigators using the same diagnostic criteria, and they have the same awareness that they have, but they're, in 1987, they're all got their hands up in the air. What is going on here? Because nothing has changed. Not even the investigators have changed, and they're seeing these increases. And of course, we now know that birth cohort 1980 roughly was the first group that got affected by the switch from aspirin to acetaminophen because of Rye syndrome, right? But the dots weren't connected at that time.
Okay, so a couple more questions before we get into the connection. Once again, first principles. What is Tylenol? We know that, everybody knows what it is. Everybody's taken it. We think of it as being benign. And I'll ask you that question later on. Has it ever been proven safe for children? But as a chemical, as a compound, what is it? How does it affect the change, or how does it do what it does?
Well, we'll pull up a slide here in a little bit that'll show you the actual structure, but it's really simple, right? It's just it's a benzene with an alcohol on, which you could call phenol, and then you put a little N-acetyl group. It's basically a little vinegar group with a nitrogen on it, and super simple. The molecule really simple, not as simple as alcohol, but it's still pretty simple.
Right. Okay, so being that, so this is sort of the first thing that I thought of when I started delving into this theory. So being that it is such a simple molecule, relatively simple, it works in a simple way, it is thought to be benign. What was the trigger, the red flag? Who decided to first look at Tylenol? Like, who would ever think to look at Tylenol during pregnancy as a connection to autism spectrum disorder?
So let me write this down, because we need to follow a little bunny trail first. So who first thought of it?
Yeah, who would think?
Yeah, who would think? So, but first, so the weird thing about acetaminophen is it's a super simple molecule, but its biology effects are profound.
Yes.
Very, very profound. Alcohol is an even simpler molecule, right? And it gives you a whole spectrum disorder, right? Called fetal alcohol spectrum disorder. So, both of those molecules, acetaminophen and alcohol, block fevers, and they block pain by two totally different mechanisms, right?
Right.
One of them is interacting with the endocannabinoid system. The other one's shutting down the hypothalamus, probably by it's inhibiting an enzyme that produces prostaglandins, which are really important lipids that help build our brains and a baby's brain. So super complicated. So, and yeah, it looks simple, and it comes in a simple bottle, and it's advertised as super safe, but it is not simple in what it does. Well, we'll get into the evidence later of some of the stuff it does. It's just shocking, and most pediatricians unfortunately don't know it. Okay, so who first? So it's a guy named Stephen Schultz, and classic case. He gave his kid an MMR vaccine. The kid regressed into autism. He was a dentist. His story, My Quest for Nathan, I think, Nathan is his son's name. It's freely available on Amazon. You can get it for free. He wrote a book about it. And he said, something happened. So he joined many, many other parents in saying something happened when that vaccine was given. But you could look at the data at that time and say it almost certainly wasn't the vaccine. And there were a lot of things. I mean, the timestamp for that vaccine doesn't even match the timestamp for the pandemic of autism. So, associations don't equal correlation, but without associations don't equal causation. But without an association, you can't have a causation, right? If the criminal wasn't there when the crime happened, then he didn't do it.
Right.
So Steve said, okay, what could it have been? And I know Steve, he did the right thing. He said, okay. So he quit his dentistry practice. He went to the University of California, got his PhD, and did this small. It's not even a small study. He had 80 kids with autism, which at that time, that's a lot of kids with autism, and compared those with controls in a survey study, and found that the common denominator was acetaminophen use. So if you just forgot about the vaccine altogether, the stats were the best, which is what we would expect. It showed a 20-fold increase, specifically in regressive autism, with acetaminophen exposure. So that
regressive autism specifically is basically it gets worse over time, or there's an onset later on.
So yeah, the onset later on. So there's basically, and we'll get into this a lot. There's two different kinds of autism, right? There's called infantile autism, which we think largely is induced after you clamp the umbilical cord, and then there's regressive autism. So the baby is making certain developmental milestones. Now, they might not be developing normally. That's a misconception, but some of them are and some of them aren't. And they have something called, we'll get into this later, they have something called oxidative stress, which really slows down development. And that's what makes them susceptible to subsequent injuries. So they may not be developing normally, but then you can see them regress and lose developmental milestones. And that's what we call regressive autism. That's what Steve was looking at, is regressive autism with this huge increase with acetaminophen use.
Understood. Okay. All right. So let's get into the details here. I mean, simple question. Okay. How is autism acetaminophen linked to the onset of autism on a molecular level, pathophysiological level?
Yeah. So I think your question is a really good leadoff question. So Steve looked at this and he said, wow, there's this huge association. So let's pull up that first slide, if you would, because it shows, it's looking at the molecular mechanisms. And this most pediatricians know acetaminophen can be dangerous under certain conditions. They just don't realize how bad it can get. So do we have that slide? Yep, here we go.
Yep, there we go.
Okay, great. So APAP, or N-acetylpyramidophenol, that's just the abbreviation we use for acetaminophen. That's that simple little molecule that I described. It's basically a phenol with a vinegar group on it with an amino with a nitrogen. So what happens with that drug is that there's two safe pathways that it can go down, and you see them there, glucuronidation and sulfation. So when Steve Schultz first figured out, wow, there's this huge association with autism and regressive autism and acetaminophen, in the literature at that time, it was already known, it's known since 1999, that children with autism can't do that top pathway, sulfation. A lot, especially with severe autism, they tend to be very impaired with sulfation pathway, which, by the way, also makes them impaired with that the other green pathway down at the bottom, the glutathione pathway, and that's related to vitamin B9 metabolism. So we can go into that later if you want. It's not my specialty, but it's not. This is not rocket science. This is basic metabolism that's been worked out for decades. And this is the other amazing thing, that you see that pathway, glucuronidation. Now, the green arrows indicate sort of safe ways to get processed for your body to process acetaminophen. But that other green arrow, glucuronidation, that one is not functional during the first weeks of life, and it's not very functional. in the first weeks of life, right when you clamp the umbilical cord. Now, pregnant mothers.
And I'm sorry to interrupt. Is that's whether you have ASD or not, just in general, the human.
Right. So everybody has increased susceptibility in the first weeks of life. Everybody does. So, and in fact, in domestic cats, they don't have this pathway functional very well. And we just don't use acetaminophen. Every veterinarian knows don't use acetaminophen in a domestic cat. And that's the reason why. And this was already known prior to 2008 when Stephen Schultz found his everything I'm showing you. So this pathway, I didn't invent anything here. Everybody knows this. This is worked out in the 1950s and 60s, literally. And then people were figuring out, wow, people with autism, they really are having, children can't process things via the glucuronidation pathway. And so what that leaves you with is that red pathway there, which is called a quinoamine. It's NAPQI. You'll see it a lot. N-acetylparaquinoamine. It's super, super toxic. It basically acts like mercury and sticks onto, it likes mitochondrial proteins for some reason, and it tends to destroy mitochondria, which will cause the cell to do what's called, and your listeners probably know about apoptosis. That's what it'll, and
programmed cell death.
Yeah, programmed cell death. And so it's just really, really can be a nasty drug, but it depends on, and this is really key. And we're going to watch a little movie here in a little while that'll sort of show people what's going on when we get to another point in this discussion. But there's this modern science, and I'm going to use the word knows, that there's this giant constellation of genetic and epigenetic and environmental factors that lead to autism. We know there's so much evidence. But what happens is that giant cloud of factors affects how you metabolize acetaminophen. So what happens is that almost everybody gets exposed to acetaminophen now, but only the susceptible children and babies and fetuses are the ones that have neurodevelopmental injury. So it's super important that what modern science knows about autism is all true, and it's part of the picture because you still need a trigger. And you say, well, how do you know that, William? Well, we're going to go through it. There's no way to explain the observations. And this is how science works, right? Is you take all the observations you can collect and see what makes sense. And that's what we're going to do.
And I think this is a very important part of the idea here, which was unfortunately I missed, which was missed or not addressed properly in the press conference, is that it's not necessarily Tylenol by itself. It's in combination with these triggers or these deficits that cause some of these pathways not to work. So you have to be
So it's sort of like codeine, right? It was in use for almost 200 years, and finally you decide, well, we just need to take it off the market because it's killing so many children because they have a certain enzyme which converts it into morphine just too rapidly, and it causes them to die because of respiratory failure. So in terms of a press conference, you probably don't need. I don't know if you want to go. For your audience, yeah, we should look at the science, and especially because people are thinking, well, it's not acetaminophen, it's this complex mix of things. We need to explain that. But for practical intents and purposes, the thing that you can control, even with coding where it's only one gene, the thing you can control is probably what you need to focus on in a press conference, I think. But
I think you're right. But it's the word susceptibility that you've used a couple of times, which I think shouldn't be overlooked.
Yeah, every time we write a sentence about acetaminophen causing autism, we include acetaminophen exposure in susceptible babies and children induces many, if not most, cases of autism. And it's like standard language because you have to have, and you can see in this diagram what happens when you have this susceptibility. Now you get an infection, and what happens? Your glutathione goes down, right? Glutathione is the master antioxidant in the body, and biochemists all over the world use measures of glutathione for measures of what we call oxidative stress. So how much stress is your body under? And the more stress you get under, which, even if this is a great example, right? If a woman was abused when she was a child, she has a greater chance of having a child with autism. That's established. But being abused as a child increases lifelong inflammation, right? So, it all adds up. It's all clean. The mechanism makes sense. That's what we're saying here. So you've got the Stephen Schultz study, right? And then you've got all this other stuff that maybe it should have in hindsight, but looking back in hindsight is never a good thing because then everything is obvious, but it is what it is. So you got all this other evidence. And then it was not until 2020 that a really incisive study came out of Johns Hopkins looking at what happens when the baby's first born, when you clamp that umbilical cord. How does the amount of acetaminophen in the baby at that time correspond with autism spectrum disorder? And the associations were huge, huge. And now again, association doesn't equal causation, but now you've got a second. And remember that previous slide, the first slide, the only slide we looked at so far, is that right when you're first born should be the most sensitive time of life, right? Because one of those whole pathways just isn't working in almost anybody. So that's what we expect, is that will be. And the other thing that you need to know is that pregnant mothers if you lined up 1 million people based on who metabolizes acetaminophen the best, the safest, and who's the worst, pregnant mothers and, oddly enough, people with cystic fibrosis would be the best. And the worst would be newborn babies and people with autism. So
right.
That's the spectrum there. So right when you clamp that umbilical cord, the game changes. And, you've got you have an organism who's a pregnant mom, and now you have two separate organisms, right? You've got a mother and a baby, and the baby is not going to be able to process xenobiotics. The only thing that our biology is that the only thing a baby really gets exposed to is the bacteria that are coming from the mom and a bunch of breast milk. And the breast milk, of course, has already been filtered through the liver. So through the mother's liver. So, that is this huge association, and it's with autism. Now, this is a different kind of autism. This is infantile autism, although they didn't, in that study from Hopkins, they didn't separate it out. But you're looking at changes in the amount of infantile autism. And the key is regressive autism and infantile autism give you the same, it's the same phenotype, but you just say the same symptoms. Those three things I talked about earlier. So it looks like it's the same cause, the same underlying problems, and the same is true with the associations in pregnancy, which we'll talk about in a minute. So that was a huge study. That wasn't until 2020. And then if you go back in time, you will see the studies in pregnancy that are starting to come out looking at associations. And data during pregnancy are a lot easier to get. So there's a lot of studies looking at associations between autism and acetaminophen use during pregnancy. So everybody who's keeping up on this knows that there's some studies that are specifically depends on how much they know, but there's a couple of studies, but one big one out of it's called the Swedish study, but it actually came out of Drexel University. It's in JAMA in 2024. JAMA in 2024. Yeah.
Acetaminophen use during pregnancy and children's risk of autism, ADHD, and intellectual disability. Right.
So that study says that there's no connection between, and I should hasten to point out that it's acetaminophen use is associated with both ADHD and autism, and I think it's consistent with what we see in the laboratory animal models it can give you. And there's a lot of similarities between those two. So if we get rid of autism, we might really reduce ADHD a lot. But so back to the Swedish study. So the Swedish study is sort of a landmark study. The NIH promoted that study. Now, the National Institutes of Health is, of course, what provides most of the funding for biomedical research, probably in the world today. So when they fund tens of thousands of studies each year, but they only do about 12 to 16 press releases per year. And they did a press release on that Swedish study because the thinking was, this is super important. People need to know this drug is safe, and we need to get this out there. And so the problem is, if you ask any statistician, you cannot treat these interacting factors, and acetaminophen interacts with all these other factors. You can't treat interacting factors as what we call confounding variables. So if it's okay now, I would love to we published a mathematical proof that the analysis in the Swedish study, it's perfectly valid, but the conclusions are completely wrong. And in that paper, it's in an MDPI journal called Life. We have the publisher put out a small video that explains that paper. It's a great video, and if we could show that now, that'd be great.
More than 25 lines of evidence have allowed some scientists to conclude that exposure of susceptible babies and children to acetaminophen causes many, if not most, cases of autism spectrum disorder. However, other studies have been published concluding that acetaminophen is perfectly safe. One underlying reason for the disagreement is due to something called confounding factors. Often, adjusting for confounding factors is a vitally important and extremely helpful part of statistical analysis. For example, drinking coffee has been associated with lung cancer in multiple studies, which means that people who drink coffee tend to have a higher risk of lung cancer. This could lead scientists to conclude that drinking coffee might cause lung cancer, but when scientists took a step back and looked at the big picture, they found a confounding factor. People who drink lots of coffee are also more likely to smoke cigarettes. When scientists adjusted for the confounding factor of smoking, they saw that there was no direct connection between coffee and lung cancer. In this case, smoking was the confounding factor that made it look like coffee might cause lung cancer, even though it doesn't. Unfortunately, some scientists made the mistake of thinking that factors related to something called oxidative stress are confounding factors that causes autism. In other words, they thought that the situation with coffee and cancer was the same as the situation with acetaminophen and autism. But overwhelming evidence tells us that this is not correct. Overwhelming evidence tells scientists that the correct equation is very different. Acetaminophen plus oxidative stress causes neurodevelopmental problems. Oxidative stress is what happens when our body can't keep up with all of life's demands on our immune system and metabolism. Overwhelming evidence also tells us that numerous genetic and environmental factors come together to cause oxidative stress, which makes babies and small children susceptible to injury by acetaminophen. In this case, the numerous genetic and environmental factors leading to oxidative stress are not confounding factors for the induction of autism. Those factors interact with acetaminophen to create injury. It is a rudimentary principle in statistics that treating interacting factors the same as confounding factors yields a false result. Computer simulations prove that even when acetaminophen exposure combined with oxidative stress causes half of all cases of autism, treating factors related to oxidative stress as confounding factors makes acetaminophen look much safer than it is, or even perfectly safe. Those computer simulations replicate the effects of published mistakes made when analyzing real-world data, shown in this graph. Some papers say that these calculations show that acetaminophen is safe, but these calculations actually show that acetaminophen will not lead to the induction of autism only if oxidative stress is sufficiently low. If individuals have sufficient oxidative stress, abundant and robust evidence demonstrates the potential for acetaminophen to induce autism. When scientists first began publishing studies of healthcare databases looking at the safety of acetaminophen in 2013, they assumed that factors related to oxidative stress might be confounding factors. More importantly, they treated those oxidative stress-related factors as confounding factors in their calculations and reported the results that way. This was strictly an assumption made at that time, with no justification. Unfortunately, this error has been propagated extensively in the medical literature, affecting dozens of publications and obscuring reality for more than a decade. The error has caused many investigators to underestimate the effect of acetaminophen on the developing brain and has caused a few to disregard it completely. It is the combined weight of evidence from numerous fields of medicine and science over many decades which gives rise to dozens of lines of independent evidence. Evidence that allows scientists to conclude that a causal relationship between acetaminophen and autism exists. As the confusion regarding confounding factors demonstrates, even rudimentary mistakes in a single type of study on the safety of acetaminophen can be very misleading.
Thank you so much, Tim. If you recall, there's two. I mean, it's amazing, and just talk to any toxicologist, any pharmacokineticist, and they'll tell you, yeah, these are acetaminophen interacts with oxidative stress. It's been known since the 1950s probably, and we looked at that slide, the first slide we looked at, right? And
Yes.
then you talk to the statisticians, like every statistician knows you cannot do that. You cannot treat And there's certain special circumstances here because a lot of healthy people are taking acetaminophen. So that really throws everything into a tailspin. We published the mathematical proof. I showed you in that video the data from our mathematical simulation, our computer simulation, and I also showed you the data from the Swedish study. That's really important. That was the Swedish study, that second set of data where you saw that everything just got canceled out. So this canceling out error, there's two things that have really derailed science. And so when you're looking at evidence for a certain model, you also have to look at evidence for people who disagree with you and say, is that valid? Why is this model better than this model? And this is one of the things that when you look at it and talk to any statistician, when I first was looking at this, I went to the full professor of statistics and said, look, we got to run these simulations, and here's the deal. You got a really common drug, and then you've got all these other interacting variables that interact with that drug to create this outcome, and we're going to treat these as confounding factors. And she just immediately, without thinking, said, that won't work. And I say, well, I know it won't work, but we have to prove it. Sort of rolled her eyes and said, okay, fine. It's a simple simulation to run, because you create the data that it took them years to get, because it's just a simulation. So that's so the things that have derailed us were, early on, it was the assumption it was safe, and we'll get to that in a little bit. But then recently, since 2013, it's been this issue of treating interacting variables as confounding factors. We saw the movie on that, and then focusing on pregnancy. And again, pregnancy is probably, and now, so we're very confident that acetaminophen interacts with susceptibility to lead to autism, but we're very confident about that. We think that most likely, so now my confidence is dropping, but most likely pregnancy is not the worst time. And the Swedish data are actually the best data. And the Swedish data published by Drexel University, first author named AHLQVIST, Alquist. So they're really the best data. And the reason why they're the best is because they published the numbers before and after the invalid adjustment. So most studies, there was a study that's often quoted by Alamini et al. That was a Spanish study that was the best study before that, arguably. But they adjusted for these factors, but you don't know what the actual numbers were before the adjustment. So that's a huge issue, is that if you only focus on pregnancy, then you've missed most of the important exposure to start with. So that's the problem going on with the mainstream view. But again, the mainstream view is still mostly correct. You still have this cloud of factors that interact, genetics, epigenetics, and it's actually called hidden heritability, because you can see that it's heritable, but you can't find the genes that are doing it, which is, and you know more about hidden heritability than I do, almost certainly, based on your field of expertise. So, and that's one of the things that tells us, well, it's probably something like acetaminophen that's very common and that everybody's getting exposed to, which makes sense.
Right. Yeah. And you've already mentioned it, but I've heard you say it a couple of times in other interviews, is that with the Swedish study, the stats were not necessarily correct or the highest of quality, but the data was impeccable, which is great, because that's data that you don't have to collect, and it's there for the world to dig through. Right.
Yeah. They did a beautiful job. They published their data. I mean, even their stats are really, really well done. You can prove they essentially, it's a good analogy is that if you say you want to test to see if it's okay for children to play with matches, which we know is a bad idea. Well, if you run the statistics so that it only counts if they're playing with wet matches, then you can prove that playing with matches is perfectly safe for children. But the problem is they don't all have wet matches, and that's true. Some of those kids have susceptibility, but they canceled that out of the equation. That's
interesting.
Yeah.
Should we address the question of whether or not Tylenol was ever proven to be safe?
Yeah. So when we first started publishing on this, we had a lot of, let's just say, Tim, we had a lot of problems publishing on this, because everybody's like, no, this drug is safe. What are you doing? And we already knew everything that that I've told you about 2008, 2009. We knew about these kids couldn't metabolize the drug. Everybody knew the drug produces a toxic metabolite. Everybody, but nobody knew the studies in laboratory animals. Well, they started coming out in 2014. So we even knew that, and I'll show you a slide with that. This stuff is amazingly toxic in a laboratory animal. So, and you're talking mice and rats, although mice are more similar to humans. So it's like, but there was a huge bias in the field. There were hundreds, and we found literally hundreds of papers that said this drug is perfectly safe when used as directed for babies and or children. So what we did then, and we had so I was at Duke University at the time, and there's some great people there. I collaborate a lot. I have a toxicologist and a pharmacologist that I've worked with for years, and combined we have over a century of experience, right? So collaboration is key. And I collaborate with the neuroscientists too, because I'm not a neuroscientist. So the bottom line is we got to figure out, well, okay, why do they think it's safe? So we collaborated with a guy he's a Canadian information scientist, and we're like, okay, why do they think it's safe? So you got to take every single paper that says it's safe when used as directed. They won't even add that. Usually it's just safe and effective. So then you got to trace back, why did they say it was safe? Mm-hmm. And then you got to, well, okay, they'll reference another paper. And then this is called citation tracking. And then they'll reference another paper.
Right.
And usually what happened was everybody sort of focused in on about 50 studies that have ever been done that had a control or not a control, but there are 50 studies, and the median follow-up time was only 2 days. So they're only looking for liver function. Now, it's been known since the 1950s, at least, that you can't treat a baby as just a small adult. So in adults, if you get too much acetaminophen, you will die from liver failure, right? So they were only looking for liver failure in babies. And we now know actually, they already knew in the 1980s that you could kill a neonatal laboratory animal with acetaminophen without hurting their liver. So it was sort of already, if the problem was, and this is a problem with science, if you don't have collaboration, you can miss things. So they did not work. Any toxicologist would know this, but they didn't have a toxicologist on the team when they initially decided it was safe and did all these studies. They're just doing clinical studies with no consult with the toxicologist. So it sort of goes back to our modern problem is they need a toxicologist and a statistician together to know that the way the Swedish paper was done, is you just can't do it that way because you will get the wrong answer. And we prove that mathematically using a computer simulation. So it goes back to these scientific errors. But the key is when you see something that doesn't make sense, like the Schultz study, then you just follow it. And then you try to figure out, okay, well, either the Schultz study was wrong or somebody else is wrong. And you try to sort through it and see who's really wrong. And right now, we've got regressive autism with postnatal exposure. We've got the peripartum when you clamp the umbilical cord, and then you've got associations with pregnancy. And I want to be real quick here to point out that it looks like with the pregnancy associations, especially looking at the Swedish data, you need a lot of exposure to run the risk up, and it still doesn't go near as high as it does with the umbilical cord exposure. I think that even with heavy use of acetaminophen, which is more rare, you don't even get quite a doubling. It's not even quite 90% increase, which is a lot, right? It's a lot, but that's the relative risk, and not that many people are using that much acetaminophen. Whereas in the cord blood study, I mean, that they just divided women into 3 groups. So a third of the women had a 3.6-fold increased risk of autism. And then with pregnancy, you're looking at a small minority of the women only had a 90% increase, or it's 3.6 versus 1.9. So the bottom line is we think that this is why we think that pregnancy is not as dangerous. But the main point here is that you got 3 different time periods of life, and all 3 are associated with acetaminophen use and connecting with autism. And autism in all 3 cases is giving you the same kind of phenotype. So you're looking at different points in time, same drug connecting to the same condition, which is very compelling. And we have a lot more evidence that we haven't gone over yet, but that's super compelling so far.
And just as a interesting point, has Tylenol ever been proven to be safe? I mean, on July 3rd in 2017, Tylenol posted on Twitter at the time, "We actually don't recommend using any of our products while pregnant. Thank you for taking the time to voice your concerns today," which was recently deleted. So, just interesting.
Well, yeah.
I mean, there's a lot of, with science and medicine, unfortunately, one of the biggest concerns that anybody ever has is liability. And I mean, that is an important thing, but it does sometimes cloud communication, judgment, and that sort of thing. So, okay, where should we go from here in terms of evidence?
Yeah, so let's talk about the evidence from laboratory animal models. If you look at that, he published this in 2014. Now, this is the first time that anybody had ever looked at how does acetaminophen affect behavior if you're exposed to it at a very early age. It's the first time anybody had looked at it in a laboratory animal. And he used mice. And those of you that are looking at this carefully, you can already see what's happened, right? So if normally, let's just think about these light gray bars first. So normally what happens is that in the top diagram, if you teach mice how to run a maze to find food, it takes them about 2 days and they get really fast. They get much faster. And if you look at the bottom diagram, they just don't make mistakes. And this is what mice do for a living. And they are good at it, right? It takes them 2 days. And you can see if they were, now the exposure level here is only 2 exposures and it's 30 milligram per kilogram. That's important. Most kids that take it orally get about 15 milligram per kilogram. You say, whoa, that is close to 30. That is really close to 30. And some kids that get suppositories get 40 milligram per kilogram. And that especially happens in very young kids. So this is not a high dose of acetaminophen. And you can see that if you get the acetaminophen, and those are in the black bars, those basically inhibit the mice when they're juvenile, when they've grown up a bit. They cannot figure out how to find that food. They keep making mistakes. So it's basically caused cognitive impairment in those laboratory animals. Now, if we had this data in 1960, we never would have approved acetaminophen for use in babies and children, and probably not during pregnancy. And if they would have done experiments, they would have required long-term follow-up, which we didn't have. Like I said, the median follow-up was only 2 days. And
so you think this data alone here would have been sufficient to prevent it from being approved?
Oh, absolutely. Yeah. Because in the modern process, right, you test stuff in laboratory animals first.
Yes, of course.
Yeah, that's just how you do it, because you don't want to give anything to a child who's, that's going to cause, this is the classic definition of a severe adverse event. You change mental function in your patient for the long haul. So I say that not because I doubt the qual. Like first, just for clarification, you've got your top graph and bottom graph. Those are the same events, the same maze, same mice, same maze. It's just looking at 2 different variables here. How long it took and how many mistakes they made along the way. Yeah. Now, don't get me wrong, Tim. They would have said, well, maybe this is a mistake, and then they would have tried to do more experiments, but then they would have found the same thing. This is. 15 different labs have been looking at, 15 different studies have been published, some by the same lab. My lab is one of them, and everybody's finding, and my lab, especially looking at rats, finds increased social anxiety with very low dose exposures. So
just as somebody who loves playing around with experimental design, just out of curiosity, are these mazes standardized worldwide?
No, they are not. So they used a figure 8 maze, which adult rats. So we have not had, a lot of people don't like a figure 8 maze. They would probably, and we don't like them either. We did other social types of tests. But we work with rats. So rats basically are too smart for the standard figure 8 mazes. They just don't want to play your game, and they'll try to get out. And they're very good at it too. Most pediatricians don't know that acetaminophen, even in adults, does target social awareness. So and the people that are studying this are looking at adults. They have no idea this in any way, shape, or form relates to autism spectrum disorder. But what you can see is that, it does affect social awareness. So something that we don't, and acetaminophen, again, is so complex. It's one of the main molecules. No reason to go on more in biochemistry. We've done enough biochemistry, but it's complex. It does a lot more reactions than just what we've shown, but they're all minor reactions. As far as, well, let's just not go there. And you can ask me questions about it if we want to, but there's a lot of minor reactions that acetaminophen does, and somehow it's affecting social awareness. It's probably not one of the main reactions. There's probably some side reactions that acetaminophen is going through in the body to create a product which is affecting social awareness, but we don't understand that very well. And of course, impairments in social awareness are a problem with autism spectrum disorder. So this is kind of like a smoking gun, because we know that social awareness is affected in people with autism. And then if you go up one more slide, this time we're looking at the timestamp. So yeah, that basically shows you the timestamp. And of course, everybody knows association doesn't equal causation. But if you've got multiple associations, and we've already talked about associations in pregnancy, in the peripartum period, and in the early childhood. So those are 3 different associations. And now we're looking at associations in time. So you're just piling on more and more associations. So if you think about, there's something in science that we use called Occam's razor, right? Where the simplest explanation that explains all the observations is probably the correct one. Now, there's a corollary to that. If you have vast differences in complexity of 2 explanations, then there's probably vast differences in the likelihood that the simpler one is correct. And that's what we're looking at here, is you get so many associations that are piling up, plus all these sort of extracurricular, these miscellaneous bits of evidence, we call it, that such as effects of social awareness in adults, that we're getting to a point where it's super, super convincing. And all the time we should keep in mind the precautionary principle. We should not have to be super convinced about this to actually make a change clinically, especially if you look at labor and delivery. This drug doesn't do any good. I mean, occasionally you'll get a high fever that maybe could put the newborn child at risk. But we have C-sections, so you can bail out of that without having to go through a long labor and delivery without a super high fever. And again, that's a rare situation. A lot of the acetaminophen is just given now as a matter of protocol and during labor and delivery. So that's a good example of something that we just don't need, and with a precautionary principle. But we're not done with the evidence yet. But what my point is here, that by now we should have enough evidence. So you and I should have never had to have this conversation, right? This should have been solved back in 2014, maybe when the first animal studies came out, or even in 2009.
And you mentioned the precautionary principle, which has always bothered me, because you're dealing with children here. And what other population, obviously they're vulnerable, but I mean, what other population do you want to, as a society, protect the most? And to be so, putting up a barrier, I don't know why it is. You can speculate why the reasons why people shut down when they hear this argument, but I mean, it's children. So I mean, you should be open to at least hearing this data. And the nice thing about this is that it's a pretty simple change.
You can always say, well, okay, there's a horrible fever, first trimester of pregnancy. What do you do? Well, I'm going to immediately say, I don't think we have evidence to support one way or the other. Again, during pregnancy, it looks like it's multiple uses repeated, probably for chronic pain management. So you can always go to sort of a worst case scenario. But you're right, Tim. It's mostly stuff that as far as we know, it's not a life-saving drug. That's certainly never been proven. And you say, well, an untreated infection is really bad in your first trimester, but the question is, you should treat an infection. Obviously, the question is,
of course,
does Tylenol help or hurt? And for long-term outcomes, and I don't think those studies have been done. And unfortunately, the NIH still has a lot of work to do about just the medicines that are most commonly used. I mean, but some of the things, like using this drug during labor and delivery, makes no sense. Giving heavy repeated doses when a child is super sick and they're under oxidative stress, that's when you're getting regression. You don't want to do that either. And, if we change that practice within 6 months, 8 months, we'll know. And the question is, how quickly will they change? Right. The question, if I can get somebody like you on ABC News, then boom, we'll be set.
I'm not sure if that's happening anytime soon, but that would be nice. You mentioned associations, and here's one I would like to get your or opinion on it. One that we hear often, and we went from about one. We're at about 1 in 31 right now in terms of children with autism in 2025. It was 1 in 150 in 2000. And in the Amish community, there are different reports, but some of the average numbers that I see is 1 in 271. What's your comment on that, or your opinion of that statistic?
Yeah, so that's a good question, and obviously we have been looking at that for years. So there's obviously, on the one hand, there's great difficulty in, say, measuring autism in a community that doesn't like to be studied, right? So if you're looking at and there's different groups of Amish which have different practices, right? I think one of the better things that we have available to us is actually Orthodox Jews. Now, Orthodox Judaism, it's not a sin for them to use drugs, but they have rituals and practices. And for example, they don't use acetaminophen with circumcision, whereas Reformed Jews do. And their birthing practices really tend to avoid any kind of drug use at all. They try to do natural birth. And you see very big differences that the Israeli government's been trying to figure out why it doesn't seem to be socioeconomic. It's religious differences in prevalence of autism spectrum disorder. So that's a really good example right there. Now, so you can look at Cuba, which I think the president mentioned, and you can look at the Amish. But again, you got problems. Maybe somebody could always argue, well, they're really there, we're just not seeing them. But the best data from Central America, super clear, unequivocal, what somebody did, and we talk about this in one of our papers, and I can dig this up for you if you want, and you can post it down here. But they went into homes or schools for children with disabilities, and you see lots and lots of Down syndrome and virtually no autism. Now, if you went in the United States and did this, it would be flipped around, because we have way more autism than we have Down syndrome. So if you calculate the ratios, we're about 600 times more autism if you use Down syndrome as a baseline. So that's from Central America, in a place with chronic shortage of modern medicine. So that's, I think, the best data right there. So if somebody wants to argue about Cuba, I'm like, well, okay, I don't know. Or the Amish, okay, we're not sure. It looks, and there's other reports in people in Africa and parts of Africa with chronic shortages of medication or just no modern medicine. They've never heard of the autism phenotype. So, you got a lot of, in people that are really skeptical. And like I said, if you're looking at the big picture, I think it's no reason for being skeptical. And we published a paper essentially with that title in the Korean Pediatric Society, published a paper, and it's been viewed almost 100,000 times. It's like, there's really no reason to be skeptical about this. You could be skeptical about one little piece of information, say, is it really that way in the Amish? But, we know the data, like I said, from Central America is super clear. So we put that in as a line of evidence that I talked to Uta Frith, who translated back in the 50s, translated Asperger's work in English. And she was one of the original people. And she said, look, we were super certain it was rare back then. Super certain. You look at Grunya Sukhareva's work, and she could only find 6 people in Russia, right, in 1925. So super rare back then. And they had drugs which were equivalent to they had essentially acetaminophen. It wasn't really, your body makes acetaminophen out of. It's called phenacetin and acetaniline. They had those starting in 1886, in 1887, but they just weren't that commonly used, and they weren't for children. So, and they weren't for babies. And there's probably some rare exposures where somebody took them right before labor and delivery or somebody tried to give them to a kid, and it just the dots never got connected. I got a little cheat sheet here, and I'm going to sort of look at it and just see if we've missed any really, really intriguing evidence. And usually by this time, we've got most of it. Mechanisms, we talked about the mechanisms are plausible. We talked about the kids with acetaminophen kids with autism can't process acetaminophen very safely. We talked about all of those things which every scientist who works in the field knows about, that, all those genetic and epigenetic environmental factors, those all make acetaminophen more dangerous. We talked about that. The Schultz study, we talked about the cord blood study. We talked about domestic cats. Oh, yeah. So one thing we didn't talk about was, so in laboratory animals, you got these 15 different studies, right? And we looked at one of them from Henrik Weiberg's lab. Well, it also turns out 4 different laboratories have shown that acetaminophen is male specific. It targets males and females in laboratory animals. And Peg McCarthy, chairwoman, University of Maryland Department of Pharmacology, is the first one to actually figure this out. So, and of course, autism is predominantly male. So
yeah,
here,
about 3.4 times more in males than in females.
Exactly. So you've got 4 different laboratories saying this drug is specific for males. It targets males more. There's some couple of different reasons why that might be going on relating to the biochemistry. And Peg McCarthy is sort of an expert in one of those. But the bottom line is, we know that it's neurotoxic and we know it's specific for males from the studies in laboratory animals. And there's a study that came out of Italy showing that it will kill cortical neurons. And there's studies in tissue culture showing that at low doses, it prevents certain neurons from branching. So it just in terms of the laboratory animal science, if we're going to listen to that at all, we should not be using this drug at all. Let's see. I think it's fun to mention, I worked with a lot of transplant surgeons, and those guys, and especially the lung transplanters, they work with cystic fibrosis patients a lot. And back in those days when we were working and I was in the lung transplant research, when we were working with those cystic fibrosis patients, their mental health was monitored very closely because cystic fibrosis was essentially a death sentence at that time. Now therapy is great. Right now, it's not a death sentence, but back then it was. So their mental health was monitored carefully. And there was never any reports of individuals with CF having autism. And CF is associated with tremendous amount of oxidative stress at the mucosal surface. But it's the opposite inside their body. In fact, it's been documented they are super metabolizers of acetaminophen. I mentioned earlier, if you lined up 1 million people, you would get pregnant women and people with cystic fibrosis are the best, and then newborn babies and kids with autism are the worst. So
I think it's important to note that cystic fibrosis is congenital. You're born with it.
That's correct.
So that's important. It's not something that you develop later on, because that would change the whole equation here.
Yeah, you're already, it's the biochemistry for acetaminophen metabolism is already hardwired in very, very early, because your body's trying to compensate for all this oxidative stress of the mucosal surface. That's how the model works there. And I think one of the big things that, we talked a little bit about the connection between fetal alcohol spectrum disorder and autism spectrum disorder. And those drugs alcohol and acetaminophen are so similar. They're both anti-fever, anti-pain medications. They both do both. And it's the same exact enzyme, right? It's cytochrome P452E1. And with acetaminophen, it's some other ones. That one of them in particular is associated with autism. But anyway, the bottom line is it's the same enzyme that produces a toxic metabolite from both of those. And in both cases, the toxic metabolite falls under the same class. Now, there's some differences in how the toxicity propagates between those two drugs, but they're so similar. And a lot of people, initially, a big question was, how can one chemical induce a whole spectrum disorder? That makes no sense. Well, the bottom line is we know that it can, because we know alcohol does it. So it doesn't tell us. It doesn't tell us how it does it. It just tells us it can do it.
Right. Exactly. Now, okay, so that's a lot of evidence there.
And we're done with the evidence, so we're good now. I just went through my little cheat sheet. I mean, there's some other little nitpicky things dealing with gut function and auditory and your ability to smell and those kind of things, but just little things from laboratory animal studies that match what we see in autism. But for the most part, that's it.
So in the best case scenario, if you were to sort of project forward into the next, let's say, short term 5 years, and the recommendations by the FDA, NIH, HHS were followed, what sort of, and strictly followed and also implemented, what sort of changes do you think we might see in the epidemiology?
There's some people I've mentioned, and I don't have their permission to say who they are, but I've mentioned them during this talk so far. We have bets on like how much it's going to drop, right? I think it's going to be right at 94.5. That's my bet, and then someone like, oh, it'll be 70% or whatever. So how much will the prevalence of autism drop? I think that is the big question. I don't think there's any question that we'll see it that'll be obvious. And I think toxicity, if you talk to a toxicologist, right, mercury poisoning looks different than lead poisoning, which looks different than arsenic poisoning, right? So This is a specific neurodevelopmental problem which has hallmarks to it, so it looks specific. So I think it's going to be a lot of it, and then there might be some others, but this is just now this is not really it's sort of a prediction, not a hypothesis. But now, how certain am I? I'm certain enough to bet a Coke, but it's not going to be, or some beverage of choice, but it's not going to be a lot of money. We have to wait and see how it plays out.
So I'm sure there's some people listening to this and thinking the obvious question: is there a safe quantity of Tylenol to take while you are pregnant? This is not medical advice. Obviously, speak to your doctor. But is the data suggesting that you take it once and this can happen, or is this an extreme situation?
Yeah, so I did. I forgot to mention one bit of evidence, but your question nailed it. So circumcision, which is a procedure, usually done very early in life. That's a single exposure to acetaminophen. That's associated with a twofold increase risk, actually slightly more, of infantile autism. So that's a single exposure, but it's the worst time of life. Now, your question is pregnancy.
Right.
Like the best data are that if you treat for occasional fever or pain, it's not number one, the mother's liver is there to protect. Number two, you still got a lot of neurodevelopmental time. Your brain your brain is plastic. It can change. So
right.
So we don't know enough to answer that question with certainty, but that would be my thinking, is that an occasional use. And, that's, again, the NIH has work to do. We got to figure all this out so we can give people really solid recommendations. And I say we, not me. As a scientist, my job is to tell the physicians associations and the regulators, this is what you ought to do. It's kind of weird, but I can't tell a patient what to do, but we publish, look, this is what the medical associations need to do. We publish that, but we can't tell an individual what they need to do. That is not ethical.
I'm just curious as an observer. Do you know if there was any particular set of data that Secretary Kennedy or HHS in general found most compelling? I know you don't like that question, but I'm just thinking from a human perspective. Is there something that really caught their attention?
Well, obviously they've read my published papers, so but they've also read a lot of other stuff. So
hard to say unless you're in the room. Yeah, for sure.
I wasn't in the room, so I don't know.
Okay, so what about ibuprofen? It has a similar effect at the end of the day. It's not the same molecule, does not follow the same pathway. And when I say effect, I mean fever relief, pain relief, not autism in general. Is it safer than Tylenol in this regard?
My understanding is right now they don't recommend ibuprofen for children under 6 months. So now if you talk about ibuprofen, you're getting a little bit out of my wheelhouse, right? I know, like, for example, they stopped using aspirin, right, because of Reye's syndrome, but Reye's syndrome mostly happens after the age of 4, whereas autism gets induced before the age of 4. So Bill Shaw and Peter Good, who are two guys that are like me writing about, hey, this is obvious, we need to stop doing this stuff. They're talking about maybe using aspirin. Now, I won't go there. I'll just say, look, there's a lot of things we haven't considered, right? So we could consider, but I say we, not me, because it's not my field of expertise. So, they're talking about the folate derivatives and how you can, one of the big things with susceptibility, we think, is apparently if you have this autoantibody that blocks folate from getting in your brain, which 72% of the kids with autism have. And this is Richard Fry's work. I know Richard, great guy, solid work, reproducible work in different cohorts. And if you can't get folate in your brain, then it creates that very first slide we showed where you can't do sulfation and you don't have glutathione to deal with the toxic metabolite. That's exactly what you get. You can look it up on Google, lots of those diagrams showing how folate's involved in all of those processes, sulfation and glutathione production. So, it's maybe that there's other things we can give to a kid if we really want to give acetaminophen for some reason, then we could give them something else to sort of boost metabolism and make them not susceptible, right? So, but again, I think we don't want to make any assumptions, and we're repeating the mistakes of the past. We actually need to do the clinical trials, and I think the NIH would totally agree with that.
So speaking of trials or further research, what would you like to see in terms of research? Now, the data is quite overwhelming, so one might argue that you don't need any more research, but there's always room for more research. Is there something specifically that you'd like to see?
Well, so I think it's a great question. I would like to see that somebody like you gets on ABC News and we stop using acetaminophen, then the rates plummet. But it can't be me because even though I don't have a conflict of interest, as most academics do, because I'm paid by a private nonprofit and my salary is set no matter what happens. Whereas, as you know, most academic researchers, the more successful your research, the more you publish in big high-profile journals, the more money you get, the more you get promoted. So somebody like you who doesn't have a dog in this fight, because you don't study acetaminophen, once they get up there and they say, hey, we need to stop this, then it'll stop and then we'll see the rates plummet. Now, in terms of research, researchers are always incentivized to say, I did really important work and more work needs to be done. And of course, I don't feel that way. I want to go do something else. I want to work on a different problem. So I won't. And I think tragically, by 2009, we could have made this change and we need to make it now. And then we'll see the rates plummet. And then there's going to be a lot of little things that need to be done. Like, okay, if it only went down to 70%, what's that other 30%? What is it? Right? Or if it went down 94.5%, well, what's that other 5.5%? So on and so on. So first we got to do this. You got to get rid of the acetaminophen-induced spectrum disorder and then see what's left, and you'll know what's left to study. And I think that's what we've got to do.
Right. Good point. Now, I brought up very early on in the discussion the fact that it is a SD spectrum. Is there any research looking at why it is a spectrum? Is it a matter of concentration exposure or time exposure, or is it just a byproduct of all these other variables, genetics, epigenetics, other environmental factors?
Yeah. So once again, you sort of look around the literature and, we've asked this question. So one obvious way to address the time exposures, say, look at the difference between regressive autism and infantile autism. And it depends on which country you look at. And there's maybe slight differences on average on the different, they have different categories of impairment, with the repetitive motion and the lack of social awareness and so on. And even the intellectual disability. And so you don't really see a consistent and certainly not a large difference between infantile and regressive autism. So I don't think it's a timing exposure. It's probably just a mixture of the amount of drug and the amount of susceptibility, just those two things, And if you have not very, if you're just right at the edge, maybe that gives you ADHD. That's probably going on, even though we don't study that. But that would be a reasonable hypothesis, I think. Some people would say that's more than a hypothesis, but we don't look at ADHD. We haven't traditionally, just because it's more of a quagmire with the diagnosis.
And I know a lot of people appreciate this, but and I like to stress it, and I have recently, is that biology is not like chemistry and not like physics in the sense that you're dealing with a living organism where there are so many confounding variables. It's multifactorial. Almost everything is multifactorial. You can open up a textbook and see a single pathway and say, that's how it works. But there's a lot that we don't know, and a lot of those paths interact with other paths. And so I think it would, a lot of hubris involved when anybody suggests that they know exactly what's happening at any given time. And so that's biology.
I get accused of having hubris because I think, because we're super confident this is what's going on. But this is how science works, right? Somebody collects enough evidence to figure out the world is not flat, right? I think that was Aristotle. And he put pieces of information together and then said it's not flat. So, it's a difference between, you've seen the evidence. So the question is, would you let your sister or your wife or your daughter would you recommend that they take a lot of acetaminophen when they go in for labor and delivery? I mean,
that's the question, isn't it? And when I mention hubris, I'm not suggesting you. I'm just suggesting that the fact that biology is complicated. And it's a susceptibility issue that I'm referring to,
No, I know. I totally understand.
Things are complicated.
Yeah, we've got a paper coming out. It's already in preprints and the same drug, outbred laboratory rats. You use 2 different groups of rats, and you get 2 totally different results. And it's one time. Yeah, and when I was in grad school, my thing is biophysics, right? And so we work on protein molecules. Mm-hmm. And I went and we were doing some stuff, and we definitely not going to go into this. But anyway, I went to the physical chemist and I said, hey man, can we run this calculation and do this thing to predict what this molecule is going to do? He said, look, William, he said, you were working with a protein, man. You want to know exactly what the molecule is going to do? Work on benzene. We can do benzene, but which is
exactly. So that's perfect example. Yeah.
Yeah. So
that's a very niche molecular example, which not everybody might get. But yeah, that's a good reason. So let me ask you a non-scientific question to sort of wrap it up. Why do you think that there is such a resistance to this idea, despite the fact that the data is good? It's a simple idea with a relatively simple solution, yet. We saw as soon as this press conference was over, there were scores of videos of people on Twitter, pregnant women, gobbling down Tylenol, and there were in fact some overdoses and some deaths as a result of that. I mean that's lunacy. But why is there such? It is tragic. Sorry, it's tragic. Yes, but why such a resistance? Anytime this, I have some ideas that I can share, but I'm curious. What do you think?
Well, we have a couple of papers out in preprint, and basically, we already talked about the scientific mistakes, right? If you believe the Swedish paper, which a lot of people still do, I mean, that paper got a huge amount of press, got pushed around the world multiple times, and then we proved that the conclusions were wrong, and then it didn't go anywhere, right? So that's tough. And then everybody's focused on pregnancy, so you got still the scientific mistakes, but there's also the emotional component, right? So if you're a physician and you worked hard to become a physician and you're board certified and you prescribe this, I've had people tell me, look, man, this is a safe drug. I have prescribed it thousands of times. We just got a reviewer, that's a formal statement of a consensus bias because mm-hmm. I've done it 1,000 times and everybody else has done it 1,000 times. It's okay. So, but the emotional compromise component is really there, right? Because you have to realize that, wow, okay. And we're not blaming the parents, certainly, and not certainly blaming the physicians. There is not a mistake to do what you're told is do the best for children, but emotionally, that's a very challenging, and it does create an emotional compromise, which leads to cognitive dissonance. So then you get what's called the invincible ignorance paradigm or invincible ignorance fallacy. No matter how much data there is, we're just not going to believe it. And then when we see that kind of thing coming from reviewers, coming from physicians, we understand that they're human. I mean, that's the problem with being human is that if you're a researcher that's been working on this 30 years and you miss the big picture, that's a hard pill to swallow, right? So it's, again, emotional compromise. There's threat to that because your lab could be shut down. We're human. And that's when I look at the gold standard of science that the NIH wants to run, I'm thinking, wow, it's going to be tough since we're humans. And, especially when people do innovative stuff, you threaten other people, and peer review is really important to keep people from going off the rails and falling off the deep end and, promoting weird theories. But peer review also prevents people from really going off on a limb and discovering something amazing and new. And so right. I think if you want, we can sort of look at, I sent you 2 more slides, one about sort of how science works. And I think this really addresses that question. So as you know, as we've discussed just briefly, I was responsible I co-discovered the function of the human vermiform appendix, which is something that Leonardo da Vinci had been working on. And this first slide really shows how that works. So there's a whole bunch of deduction. There's a whole bunch of information that you have to know. And if it's got a box around it, that means I specifically worked on it. It means doesn't necessarily mean I'm the guy that did all the work. Sort of like with the laboratory animal stuff, I did some work on it, but there's lots of other people that did too. So same deal here.
Just to preface this by saying this is sort of a visual representation of the scientific method as it pertains to your research on the appendix.
Right. And the first thing you have to figure out is that, wow, the immune system is not just trying to constantly fight back your gut bacteria. It was a model. It came from a paper in 1972 in Science, and everybody believed that it was right, that our immune system was constantly battling our bacteria to keep it at bay. And then you had to know this was way more complicated. And we're not going to go into a detail. This is way more complicated than figuring out how autism is induced, because you're trying to figure out how these complex colonies of bacteria are interacting with your immune system and how the overall geometry of the gut works. And so you make these deductions in sequence, right? And so the first deduction is that the bacteria are actually benefiting from being recognized by your immune system. And then the next deduction is that your immune system is supporting the growth of beneficial bacteria. Now, that's widely known right now. Everybody believes that. But when we first figured it out, I really offended a lot of people and friends of mine that I would talk to them and say, hey, look, look at this data. And I was so excited, and they would get mad at me, right? Because they had worked with a totally different model their whole life. Mm-hmm. And I was saying that they were wrong. Now, I was thinking, wow, I'm really excited because this is so cool. And they would just get mad at me. And these are my friends, right? And, we talk it through, and we're still friends now. And then, like I said, everybody believes this now because it's so obvious. But it wasn't obvious at that time. And then you go down, and when you finally get to the deduction of what the human appendix is for, I really didn't offend anybody with that. So that was cool, because then you've got, the only reason that we figured that out is because I was collaborating with a guy named Randy Bollinger, a great friend, who was taking out people's appendices every day. So I understood how everything worked perfectly in a rat, and I understood the geometry, but he was thinking about an appendix. And one day he just said, I bet that's what the appendix was for. And then boom, he didn't even have to tell me what the answer was, because it was immediately obvious, because I knew all those other stuff in this diagram. Right. So this is how, in Occam's razor applies, simplest explanation fits all these explanations, and then we can throw out existing paradigms, which we can see are wrong. We can run tests and see if the conclusions predict what happens in reality. And, I could put up other diagrams. And my lab was the first one to predict that the clinical impact of COVID would be much less severe in ultra low income countries. A lot of other stuff we've done. I'm an old guy, right? I've done a lot of cool stuff all these years. So let's go to the next slide. All right. So this is how we did. And I say we, it wasn't me, right? I wasn't the first guy to do. Now, there's a lot of stuff on here that I helped put on here. And again, the boxes are on there, but like I said, a guy named Peter Good in 2009, and then Bill Shaw in 2013, they really had it put together. They just didn't. I just keep putting more and more and more and more evidence in. Plus, I'm the only academic that's really working on this. So that's kind of where we're at now. And you can see that there's one kind of big deduction there. You could lump those two together. They don't have to be sequential like the last one was, but that's how the science works. Is you look at all the observations, put everything together, and really importantly, you look at why other people are thinking what they're thinking. And we saw that video. And say, okay, why did they cancel out? Why did they make the assumption that these interacting variables are really just confounding factors? You can trace that back to a paper in 2013. And so you just go through systematically and evaluate one model versus another model, and then you come up with a conclusion. That's, it's the same thing we did with the human appendix. Right.
No, this is beautifully laid out. Thank you. And also your previous example with your surgeon and the appendices. I mean, what a great example of a multidisciplinary, approach or teamwork that really helps things move forward, right? which you sort of at the top of the of our discussion laid that out, that it's really important that you work in teams with your strengths and your weaknesses.
Absolutely, yeah. And and if your toxicologist tells you, no, William, this isn't right. Like, so for example, you asked me a question earlier. Would that data have prevented acetaminophen from getting through the FDA approval process? Absolutely, yes. But the toxicologist told me, look, a company could still, if that data didn't exist, they could still sneak something like that through, even in today's environment, right? You can pick models which make your drug work better. You can miss things. Now, of course, not in your company's best interest to do this in the long run, because you're going to put a really bad drug through, but you can still. But right now, we know so much about acetaminophen, it could never make it through. But if they were starting from scratch, another drug could still make it through like this, which I initially thought wasn't possible. But if you talk to people in the field, they say, yeah, it's still possible.
Right. Okay, wrapping up with a question that I ask everybody. What would your from your perspective, where you stand now, which is not a simple position to be in, what would your advice be to scientists that are coming up, either researchers, clinicians, that are studying controversial topics and may feel like they're up against the wall? What would your advice be to them?
Well, Tim, I know that you like to encourage people to go into science, right?
Yes.
Are you sure you want to ask me this question?
Yeah, no, let's keep it open. I mean, I love science, but I'm a realist. I get it.
So, all right. Well, you should, if you don't like what I'm going to say, you should edit this out, man. That's what I'm going to say. So,
all right, deal.
All right. So, yeah. Okay. So, if you got to understand, when you go into graduate school, you immediately encounter a situation in which your career is in an existential crisis, right? Mm-hmm. If you're an advisor or some members of your committee don't like you, you're not going to make it, right? And then you go through a postdoc where same thing, constant existential crisis. And so when you look at the overall, only 10 people are making it in academics per every 100 that go in to the graduate program. And then once you get in academics, you're still in an existential crisis until you get tenure, right? And if you get tenure, what it means is you've learned to work with the peer review system and not buck the system, right?
Within the rules.
Yeah. So there are rules that you play by that you don't offend people. So this is how peer review works. So the NIH has tried to make reforms where you support the investigator and not the project, but those are tough. And, the rich tend to get richer that way. Is a hard system. And if you do really, really innovative stuff, you will not be rewarded for it, at least maybe not in your lifetime. I mean, look at Galileo, right? It's a lot of that kind of, I had to retire from Duke University at the age of 55. I'm an associate professor without tenure. So but you look at the stuff I published, like, wow, this guy is doing stuff that is really consistently bucking the paradigm and then gets proven to be true, but I never got NIH funding for figuring out how the immune system interacts with the bacteria. I mean, everybody just said, no, this is ridiculous. And then one grant application, one reviewer said, everybody already knows this. And the other said, this is ridiculous. And when that happens, then, for these grants to get funded, you have to have 3 perfect reviews, right? So and there were other projects that I could have done that I had good reason to believe they would not lead to an improvement in human health for the population. And I passed up on those, but they would have been good for funding. So I think it's just tough. It's tough. And if most people who are really creative and love science will get so agitated by the other things that are going on that they will drop out. So, and I always encourage my students, make sure you have a backup plan. Number one, make sure that you don't take it personally. If you want to do science, just don't take it personally. and just enjoy science and understand that there's a lot of stuff that goes on in science that can make it, I love science, but do I love how we do science with a peer review system? No, I do not. So that's, but you put in that political reality where you have to deal with a system that is, and if you want to know about science, just look up competition, existential threat, and something called threat rigidity, which is what it creates in the human psyche if you're constantly under survival pressure. You basically, this is why a lot of my reviewers get mad at me, and you can tell they're writing angry responses because I'm threatening to them. Right. And I get it. It doesn't make me mad. I understand where they're at. It's sad, but this is how the system works.
Right. So I think reading between the lines, it's basically very similar to what I tell my students is that, the science game or the science career path and life in general is a game. There are rules. Learn to play within the rules and between the rules because that's how a game works. So think about it that way. And
that's a really good way to look at it, Tim. It's a game, and just don't get emotionally invested. And I say, look, you need something you're passionate about, but don't make that science. It could be science, but then don't be a professional scientist. Whatever you're passionate about, don't let that be where your money comes from. I have a wonderful wife. I have many friends, and I'm a blacksmith, right? I do a lot. I've worked with the Scouts for decades. There's a lot of things that I do. I'm passionate about science. I am not passionate about science. There's nope, not passionate at all about science. I'm good at it. I don't like it. So, it's what I need to be doing. So that's what I'll do.
Well said. Dr. William Parker, it was an absolute pleasure speaking with you. I hope this informs people more than just a simple press conference or a soundbite on TV. So I hope people find it valuable. Thank you for joining me.
Yeah, you're very, very welcome, Tim. It's my pleasure.